All right, let's do this. Okay, so the baseball is popped up and caught at the same elevation. Okay, so you just have to picture this. It's a physics word problem. Like the batter hits the ball here. Ball goes up, goes down. Now it's going to spend half the time going up and half the time going down. Okay, so the time it spends going up is just going to be half this total time in the air. So that's as simple as that is, right? Because it's the same elevation. So the first question is just we're going to go 8.32 divided by 2. That's 4.16. Now to find the initial velocity, okay, we are going to we're going to go from the ground to the top. And I'll show you why we do this. Because if we go from the ground to the top, remember the final velocity at the top is 0. That gives us one value. We know the acceleration all the way up was negative. We know that the initial velocity, we don't know what it is, right? But we know the time is 4.16, okay? And so we can figure out the initial velocity, and I'm just going to use no s. So v is u plus at, okay? So 0 equals u plus negative 9.81 times t. And then if we solve this, right, ultimately, the t is 4.16, right? Okay, if we solve this, the u is just going to be the opposite of this term here, right? So it's going to be 9.81 times 4.16, and that's 40.8096. And we're going to use this. Now, obviously, for the answer, we'd round it to 3 sig figs, right? We'd say u equals 40.8 meters per second. That's a 4. There we go. And if you want to really emphasize that it's upward, you can put a plus there. You don't have to, but there it is, right? So that's the answer to the second question, right? It said that it had to be launched at 40.8 meters per second, okay? But then it says, what two velocities does it have when it reaches an elevation of 60 meters? Well, I'm going to have to erase here, okay? But 60 meters, this thing actually goes like 84 meters or something like that, right? So 60 meters is somewhere here. There ought to be some way that we can get, because it's going to pass 60 meters twice, once on the way up, once on the way down, okay? So to get this answer, we're going to have to somehow get two different values, right? Which seems strange, but I'll show you how it works, okay? So I'm going to erase here. 3, 2, 1, erase, okay? Here's the level that it's hit. It goes up to about 84 meters or something like that, right? It goes down. 60 meters is here. And now we're going to do we're going to suvot from release to 60 meters, okay? Okay, so we're going to go from the ground to 60 meters. It's always important to know what you're suvotting. If you don't know what you're suvotting, you're going to make silly mistakes. Okay? So, of course, we know the displacement is 60 meters. Now, whether it's 60 meters the first time when you pass it, or whether it's the 60 meters on the way down, I don't know, right? We know that our initial velocity is 40.8096. Okay? I got this from the previous part of the problem, right? Okay, the final velocity is not 0 because we're not at the top, right? This is negative 9.81. And we have three things, right? We don't know the time, we don't know the v. Okay? So I'm going to use no t to find v. Let's do that. And now here it is. This is the crux of it, right? If I solve for v, I take the square root of a square. So all I know is that the absolute value of v is the square root of 40.8096 squared plus 2 times negative 9.81 times 60. Notice the 60 is positive, the 9.81 is negative. That's going to make this, the value of this square root, less than 40.8096. Okay, so let's do this. Square root of, now I just typed the square root. I'm hitting the up arrow to grab that 40.8096 because I'm too lazy to type it in. And then I hit squared, and I go plus 2 times negative 9.81 times 60. Now, by the way, if you pick too high a height, there is no answer to this, right? Like if I picked 100 meters, well, it doesn't go 100 meters, right? So this, if it bombs, and I get 22, I get the final velocity is, the absolute value of the final velocity is 22.095779906, et cetera, meters per second, right? Okay, that means if it's the absolute value is this, that means that the velocity can be positive 22.1 meters per second or negative 22.1 meters per second. And of course, the positive value is when it passes this on the way up. The negative value is when it passes it on the way down. Conservation of energy actually states that for any given elevation, right, the potential energy is the same, so therefore the kinetic energy is the same, which means it's, at any elevation it's going the same speed, which is a good rule of thumb, right? Okay, it's just the direction changes. Okay, now keep this number in your calculator because we're going to use it for the next part, but I'm going to put that in a different video because this video is getting kind of long, okay? That number, we're going to use that number. Okay, all right.